Hi guys, Math 116, section 1.1, looking at linear equalities and inequalities, solving for x problems. So here's question number 9 on page 62. Thought I would look at a problem and show you some of the basics of solving these linear equations. So we have 8 minus 2 times 3x plus 9 minus 6x equals 50. And it says solve for x. This is the, at least they didn't say find x, right? That's the joke. It's right there. Okay, so the first thing you want to do is multiply this 2 out. So we get, that's a 2, it's hard to read. You get 8 minus 6x, because that's 2 times 3, minus 18, because that's 2 times 9, minus 6x equals 50. So distribute everything out so it's all on a line like this. And then you want to start adding like terms. So by that I mean, if there's any x's, let's get those together. So that's negative 12x, because it was negative 6 and negative 6. We can add those together. It's minus 12. And then we have 8 and negative 18, so that's minus 10 right there. Minus 10 equals 50. And our goal is to get something that looks like x equals blank. So we're working towards getting x by itself. So we can add, you see this little minus 10 is a problem. So we add 10 to both sides. And then that gives us, on this side, minus 12x equals 60. So again, I'm trying to get this piece all by itself. And I knew that this minus 10 was a problem. So in order to get rid of the minus 10, I added 10. But what you do to one side, you have to do the other. So it's 60 on this side. And now if we're getting close, we just have this minus 12 to deal with. Well, the way to deal with that is divide everything by negative 12. And what you do to one side, you have to do to the other side. That maintains the equality. So now we have x equals, see how the negative 12s cancel? And we have 60 divided by negative 12 is negative 5. Ta-da! Does that work? Now let's go check our solution. We're going to check. I'm going to pause. I'm going to give you a new page. And we found our answer as x equals negative 5. And the question is, does this work? So you can check your answers here if you had time on the SAT or whatever you're doing. 8 minus 2 times 3. And now I'm saying we're going to try negative 5 in there. Plus 9 minus 6 times negative 5. And the question is, does that equal 50? So, does it? Let's find out. Okay, so this piece is kind of a mess. This is negative 15 plus 9, which goes to negative 6. So we have 8 minus 2 times negative 6. So 8 minus 2 is there, times negative 6, minus this piece right here. 6 times negative 5 is negative 30. You got to be careful with these negatives, man. They will mess you up. You have 8. Oh, look at this. Minus minus plus 12 minus minus plus 30. I think we see it. I can see it from here. 20 plus 30 equals 50. Yay! It does equal 50. Good check. Good. Well checked, people. So that's how you check your answers. You could also go to the back of the book and check. I know some of you are thinking, I just went to the book and checked. But you won't be able to go to the book on a test, but you can plug in your own problem. Okay, let's look at another one. Another one of these equalities. Problem, which is question number 27. This is a solve for y. Sometimes you get these problems where you have two variables and you have to shift the equation around so it's written in terms of one variable. So we have 9x plus 3 halves y equals 11, and the question says solve for y, and it's going to be equals something or other with an x. So y in terms of x. So now we want y by itself. We're going to do roughly the same thing we did before. So in order to get y by itself, we have this problem here, this 9x. So I subtract 9x from both sides, and that gives me 3 halves y equals 11 minus 9x. So the 9x plus 9x minus 9x went away. So we're getting close. We want y by itself. So this 3 halves is a problem. I'm going to do it in 2 little steps. First of all, multiplying everything by 2. Some of you will just go ahead and multiply everything by 2/3, but I'm going to do it in this little baby step. So this is 3y. Multiplying this side by 2 is 22 minus 9 times 2, which is 18. There. I got a little stuck. I got a way out. So I multiplied both sides by 2. Now I just have a 3y. And now I'm going to want y by itself. I'm almost done. The problem is this 3, so I divide everything by 3. Or you can multiply by 1/3, whichever way you want to think of it. Divided by 3. So our answer over here is y, the 3's cancel, is equal to 22 divided by 3 minus that 18 divided by 3 is 6 minus 6x. So now we have solved the problem for y in terms of x. Okay, let's do another one. Problems have inequalities instead of equalities, and this is question number 41, asking you to solve for x and graph. So we have 3x divided by 4 minus 1/6 is less than, making sure I can find the problem, less than x minus 2 parentheses x minus 1 all divided by 3. So this is kind of a mess, but we can do it. And the trick here is this is a less than, not a less than or equal to, so let's just follow that through as we go along. So one thing I'm noticing as I look at this problem is I don't like these fractions. They kind of bug me. So if I multiply, I think, well, there's a 6 and a 4 and a 3. And I think, well, 6 times 4, that's 24. And the nice thing about that is 24, there's like 3 times 8 is also equal to 24. So I'm going to multiply everything by 24, and then I can cancel a lot of these fractions. So this will work. You can do this a lot of different ways, but this is the way I like to do it. So I'm multiplying everything by 24. What you do to one side, you do to the other, and this maintains the inequality. I think of them as scales that are perfectly off balance, and as long as you don't change it too much. So this leaves a 6 there. So now I have 3x times 6 minus the 24 divided by 6 leaves a 4, minus 4 is less than 24x. There was nothing to cancel on that side, so that's just 24x minus 3, and the 24 cancels, and that leaves an 8. So we have 2 times 8 times x minus 1, like this. And that's still a little messy, but it's actually better because I don't have the fractions. So now I'm going to simplify again. So that's 18x, 6 times 3 minus 4 is less than 24 minus, this whole piece is 16x, that's 16 times x, and then 16 times negative 1 is 16 minus x. So now I have to distribute the minus, so it's minus 16x, and then the minus, plus 16. I'm telling you, those negatives will come back to bite ya. So, oops, I forgot. I was like, why does this look wrong? So I'm missing an x. Okay, so I have 18x on this side, minus 4. I'm just going to leave this side alone for a second and clean up this side. I have 24x minus 16x is 8x plus 16. So now I want my x's all on one side. So I'm going to subtract 8x here, minus 8x. That gives me 10x. And then I'm going to add 4. Add 4. That gives me 20 on this side. This inequality keeps going down, less than. And now the only problem, I'm almost done. I have x by itself except for this 10. So I'm going to divide everything by 10. Divided by 10. And it all leads to, yes, you can see it, x less than 2. So then the problem says to graph this. So this will, I should get a new picture out, but I'm not going to. Here's 0, here's 1, here's 2. If you wanted to show this, x less than 2, what you could do is put a big circle here, because I'm not going to include 2, so I put an open circle, and I could be fancy and make a line here like this. The graph goes like that. Down. Pretty fancy picture, huh? Okay, let me look at one more. Let's look at one more of these. I wanted to show you how these equalities can work in action. So I'm looking at question number 51. Wow. Question number 51 on page 63, and it's talking about internet access. It says P equals the percent of the U.S. population with internet access, percent with internet access, and T equals access. Sorry, I did kind of access that's a mess. And then T equals time, number of years past 2000. Past the year 2000. And here's the formula they give you. 4 times P, the percent, minus 11T equals 200.7. So part A says what percent of the U.S. population had internet access? So what is P? What percent? What is P when in internet access in 2010? When T equals not 2010, but 10, because we're years past the year 2000. So we're basically saying, all right, I want to know what is P when T equals 10. So I'm going to plug T equals 10 into this equation. So I have 4P minus 11 times 10 equals 200.7, right? And this turns into 4P is equal to, hold on, wait for it, 310.7. Divide everything by 4. So again, we're doing the same sort of thing. We want P by itself. So now we're dividing everything by 4. And we're back to our solution of P equal 77.67. So this is a percent. 77.675. So about 77% of the households had internet in 2010. So 77% in 2010. Let's look at part B. Hang on. Okay, so part B says, in what year will 90% have access? So what is T? In what year means what is T when P, when 90% have access? And this is something to notice here. In this case, they want P equal to 90, so don't write P equals 0.90, which would be like 90%. That's not going to work. In this case, it's actually 90, which is a bit unusual, honestly. So we were going to plug in P equals 90 into our equation, 4 times 90 minus 11 times T, and we're going to solve for T, for time. So now I can put the T on the other side here. So 4 times 90 is 13. I'm kind of doing a couple of different steps here all at once. I'm looking at my notes. 139. This is 4 times 90 minus 200.7 equals 11T. So I'm putting the plus 11T on either side. So now I'm going to solve for T. It's 159.3 divided by 11, which is 14.48. So I'm saying T equals 14.4, but remember that's time since 2000, so you add that to the year 2000 to get about 2014, sometime in the middle of 2014 or 2015. Well, because you went past 2014, so you're into the year 2015. So maybe about July, June, mid-June. Anyway, that's how you solve those problems. You look at the number that you're given and you solve for the one that you're trying to find. Okay, on to 1.2.